Hi, Pankudi. I've got to go quick because there is a time limit on this, but these are some pretty standard probability questions. The first one I'm not entirely sure can be solved using a tree diagram, so I'll just show you the pretty standard way of solving this. So here I have a chart representing 2 dice rolls, 1 through 6, and the 36 possible sum combinations. And so we're just going to count the number of sums that are either less than 7 or divisible by 3. So we'll put a dot next to all of the 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 total that are less than 7. And then we're going to put a dot next to all of the divisible by 3 sums. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. But now you see we've double counted some of these. There are some that are both less than 7 and divisible by 3. And so we're going to take note of 1, 2, 3, 4, 5, 6, 7 double counts. And we're going to subtract 1 instance of each of those double counts from the total, giving us 15 plus 12 is 27, minus 7 is 20, divided by 36. That's our final answer, which can be reduced down to 5/9, which is equal to 55, or which is the same as 55.5 repeating percent. On to the next question. Oops, this one about teachers with cars and desktops. We know that the probability that a teacher has a car is 0.72, which means that the probability that a teacher does not have a car is 0.28. If they do have one, we'll put it on the left. If they don't have one, we'll put it on the right. So then the probability that a teacher has both is a yes to both the car and the desktop, which means on the far left we have 0.37. And since the amount of teachers with cars that have both that have either a desktop or not a desktop has to sum to the number of teachers that have cars, we can find the number of teachers or the percentage of teachers that do have cars but do not have desktops by simply subtracting 0.37 from 0.72, giving us 0.35. So 35% of teachers have a car but not a desktop at home. And finally, we're given that the probability that a teacher has neither is 0.08. And since we're trying to find the probability that a teacher does not have a car but does have a desktop, we're going to follow this line and basically we're going to take 1, which is 100%, minus all of these percentages, which will give us a sum total of 0.2. So our final answer, the probability that a teacher has a desktop but does not have a car is 0.2. There we go, 0.2. And then finally, kind of the same idea. So Alex and Ted are close friends. We're just going to straight up now, we're going to label this top row Alex and this bottom row Ted. Now we want to find the probability that they go to different universities. So on one side, we're going to have the probability that one of them goes to Queens, and the probability that one of them goes to Ryerson. So we know that the probability that Alex goes to Queens is 0.75, which means that the probability that he goes to Ryerson is 0.25. We have the probability that that Ted goes to Queens if Alex goes to Queens is 0.93, which means that this here, where they both go to Queens, isn't just 0.93. It's the probability that Ted goes given that Alex goes. So it's 0.93 times 0.75, which is equal to 0.6975. And we have the probability that Ted goes to Ryerson if Alex goes to Ryerson is 0.62. So again, we have 0.62 times 0.25, which gives us a sum total or grand total product of 0.155. And so now we just need to find the probability that they will go to different universities, which is exactly these two missing slots here. And so you find that the answer there is 1 minus 0.155 minus 0.6975, which is equal to 0.1475, which is the final answer.